Hello, everyone. Hi there. My name is David from the Ontario Science Centre, and I'm not actually at the Ontario Science Centre right now. I mean that sort of in the philosophical sense. As you can see, I am currently in my basement, as evidenced by my beautiful plants behind me. When I'm at the Ontario Science Centre, though, I teach school programs, so I can teach anything from kindergarten up to grade 12. If a class comes to visit on a field trip, then maybe I'll be the one to teach your class. And with the Science Center building closed right now, I thought it would be fun if I ran an online class for you. Okay, so today's video is going to be about one of my favorite topics. I want to talk to you about math and numbers, and then maybe show you some cool things that you can do with them. Like I mentioned before, I often teach kids at the Science Center, so this will definitely be kid-friendly, but I like adults too, personally, so I'm going to make sure I include some stuff for people of all ages. So no matter how old you are or how much math you've studied, the most important thing to me is that you participate. Because when we teach classes at the Science Center, we always make sure we include lots of fun things that you get to try for yourselves. So if you would like to play along at home today, go ahead and grab yourself a calculator. Just the one on your cell phone is perfectly fine. My calculator is a bit broken, maybe because I use it so much. So I had to borrow my partner's while she's working. And you might also want some scrap paper or something to write with, just in case. Okay, so let's get started. So when you think about math, you're probably thinking about numbers, and most of us even have a favorite number. When I was growing up, my favorite number was 13, because it's supposed to be unlucky, and I was like being young and edgy, so I thought it was like cool to like the number 13. Now my favorite number is 1, and that's because it rhymes with my last name. David Yan, number 1, just rolls off the tongue, so that's why I like that one. Mostly I'm just stalling right now to give you time to get your calculator, so if you don't have one yet, you still have time to get one. If you do already have one, though, I'm going to show you a really cool number, another number that I like. So I got my little trusty whiteboard here. Okay, so here is a really cool number that I like. The number is 142,587. Sorry, 857. I got that a little bit backwards. 857. Okay, here's a really cool number. This number is sometimes called the Phoenix number or the cyclic number because it has this really cool property. So what I want you to do is on your calculator, try entering this number. So 142,857. And then I want you to try multiplying it by 2. So do times 2. And what do you notice about what you get? So if you've done on your calculator, what you get is 285,714. And what you'll notice about this number is it's exactly the same digits as the original number you started with. All it is we took like this 14 from the start and we moved it all the way to the end. Now, the really cool thing about this number is that it doesn't just work for that. It also works if you multiply it by other numbers. So try entering that number again in your calculator. So the number again is 142,857. And then this time, try multiplying it by 3. So if you do times 3 this time, again, you'll get something that's just the same original digits rearranged. So this time you get 428,571. So this time you'll notice it's as if you took this 1 and you just moved it to the end. And you can do the same thing you could try multiplying it by 4 or 5 or 6, and you will get an equally cool result. So that's one of my favorite numbers. It's called the Phoenix number. Okay, here's a trick that you can try at home on your calculator, assuming that you've got one. So this is what I want you to do. That was the number that I picked, but now I want you to pick your own number. This time, I want you to pick any 4-digit number. Any 4-digit number. So I'll just pick a random one. I'll say like 8173 or something like that. And then what I want you to do is I want you to enter that into your calculator, and then you're going to enter it twice. So I'm just going to repeat it like this. So now you should have an 8-digit number on your calculator. Okay, so here's mine as an example. Now, here's the steps I want you to follow. I want you to try dividing your number by 137. Divide your number by 137 on your calculator. And you should get a whole number. Your number should be perfectly divisible by 137. Okay, now that you've done that, I want you to divide by your original number. So now divide by your original 4-digit number. So in my case, I would divide by 8173. Okay? So you want to divide by your original number. And here's the thing, is even though I have no idea what 4-digit number you picked to start with, I know your answer is exactly the same as the answer I'm going to get. I know that your answer on your calculator is 73. So if you got 73 and you're impressed by that, then that's absolutely a trick you can try with your friends and family at home. It's the amazing 73 trick. Here's another cool trick you can try on your calculator at home. So this time I want you to pick any 2-digit number. So you could pick something like, let's see, what's a good 2-digit number? 65. And then I want you to follow these steps on your calculator. First, I want you to multiply your number by 3. Try doing times 3. And then just leave your answer that you get there. Next, multiply whatever you get by 7. Give you some time so you can do that. Then I want you to multiply it by 37. And now finally, I want you to multiply it by 13, which was my favorite number as a kid. And here's the cool thing you should notice. When you multiply your 2-digit number by 3, then 7, then 37, then 13, your answer should be the same number you started with 3 times in a row. So in my case, I would end up getting 65, 65, 65. That is a cool calculator trick that you can try on your own. Okay, now that we've done a little bit of a warm-up, I thought I'd talk some more about why I like math or some things I often hear people say about math. So one common thing that I hear people say is, I'm not a math person, or I can't do math. And it's definitely a polarizing subject. Here's the thing though, is you can and you do math all the time, and you're just not giving yourself credit for it. It's like for a long time, people didn't do any math at all. And that's because math hasn't been around forever. It had to be invented, just like everything else humans have invented. The first math that was ever invented was counting. So it might seem weird to think about, but people didn't always know how to count. It was like 20,000 years ago, something like that, that we have discovered evidence of the first people making like tick marks on a piece of bone. So before that, people didn't know how to count. So if you can count, then your math skills are already way ahead of lots of people who have lived throughout history. Anytime you use numbers in your life, so if you're counting, if you're like reading the clock, if you're making change with money, anything like that, that's all type of math. But there's actually a lot of math that we can do that doesn't even use numbers. So like when I studied math in school, I found that the farther I went in school, the less we actually used numbers in our classes. So by the time I got to like my 3rd year of university, some of my classes hardly had any numbers at all. But today, what I want to show you, if you saw the promotional picture for this is the puzzle that was in the promotional picture. It's a math problem that you can try at home that doesn't actually use any numbers. It's all about drawing shapes. Okay, so here is what the challenge is. The challenge is to see how many ways you can connect 10 dots. So we're going to draw 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the challenge is to see how many ways can we connect 10 dots. There's only 2 rules for our connections. The first rule is that we can't have any little like cycles or circles like this where you connect like, you see how these 3 dots are connected in a ring? You can't have anything like that. That's the first rule. So that's not allowed. And the second rule is you can't have any dots that only have 2 connections. So do you see how this dot in the middle is connected to just 2 other dots? That's not allowed. These dots are okay because they're only connected to 1 dot, and you're perfectly allowed to have a dot connected to like 3 or 4 or 5, just not exactly 2. Okay, those are the 2 rules. And now the challenge is how many ways can you connect 10 dots? Sometimes it helps to see an example, so I'm going to show you one way to do it. This is probably the simplest one, is you can just draw 1 dot in the middle and then connect 9 dots around it, sort of looking like a sun or like some sort of virus, maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9 around the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one possible solution. And the challenge is to see if you can come up with all 10 of them. There's 10 different pictures that you can draw connecting 10 dots. This puzzle actually comes from a movie called Good Will Hunting, which came out like a long time ago, back in a decade called the 90s. And in that movie, there's a math professor, and he tells his students that it took him and his colleagues 2 years to find the answer to this problem, which I think is a little bit of an exaggeration. And that's actually one of my biggest pet peeves about the way they show math in TVs and movies. They always try to make it sound like math is like this super scary, like impossible thing. Don't get me wrong, some math problems actually do take 2 years to solve, but this is definitely not one of them. So depending on how much you like drawing, I bet you can definitely find most of the 10 possible shapes in like an hour tops, not 2 years. And you definitely don't need to be like a math professor to be able to do it. The most advanced math you need to know to be able to do this is you have to be able to count to 10. That's it. As long as you can count to 10, you can try this puzzle at home. All right. Now I know for a lot of you watching the stream today, I did say I was going to make it kid friendly. So like Good Will Hunting might be a bit of a dated reference. A lot of you might not remember the 2000s, let alone the 90s. So I want to talk about a more recent movie, the movie Frozen. I do have to start by confessing to you that I've only seen the first Frozen. I still need to get caught up and watch Frozen 2. But in that first movie, there's this scene where Elsa, she's running away from the castle, and she starts running across the water. And as she runs, the water behind her, it freezes completely solid. And it takes a lot of energy to make things freeze. So that's like why we have to plug our refrigerators into the wall. It takes energy to make things cold. And the bigger the thing is, the more energy it's going to take to freeze it. So I have this friend. His name is Aaron, and he loves math, and he's a huge Elsa fan. So what he decided to do was use math to try to figure out just how powerful she is. And what he did was he estimated how much water was in the fjord that she ran across. And then he used that to figure out how much energy it would take to freeze all of it. So as it turns out, it's actually a huge, huge amount. It's more energy than 50 nuclear bombs combined. And now that I know that, it makes me appreciate Elsa even more. The kind of magic that Elsa does in the movie Frozen is like real magic, and I can't do anything like that. But I do like to do card tricks, which is like a different kind of magic. So I'm going to try and do a card trick for you. So I'll lower my camera down here so you can see my cards. Okay, here are my cards. So for this trick, you need 10 playing cards, and you're going to, this is how you're going to choose them. You're going to choose 5 red cards and 5 black cards. So I just have ace through 5 of red and black. We're going to put them in order like this to start. But then we're going to try mixing them up. So I'm just going to cut the cards a few times just to switch their order. So I'll do that maybe 3 or 4 times. Okay, here we go. Now what I'm going to do is I'm going to separate the cards into 2 piles. So I'm going to deal down 5 cards here, 2, 3, 4, 5. Then I'm going to leave the other 5 in a pile over here. Now this is where the trick comes in. Is what I'm going to do is I'm going to take the top card from each pile and move it to the bottom. And I'm going to do that 4 times in total. But I'm not going to be the one to decide how I do it. I'm going to ask my assistant to do that for me. So we're going to choose 2 numbers that add up to 4. So it could be like 4 and 0 or 3 and 1, 2 and 2. I'm going to let my assistant choose. So give me 2 numbers that add up to 4. So 3 and 1. Excellent. So my assistant just off screen here has chosen that. So we'll do that 3 times to this pile. 1, 2, 3. And we'll do it 1 time to this pile. 1. We're going to take off the top 2 cards from each pile, and we're going to set them to the side for later. Okay, we're going to do the same thing again, but this time only 3 times. So give me 2 numbers that add up to 3 this time. 2 and 1. Okay, so we'll do it 2 times over here. 1, 2. And we'll do it 1 time over here. 1. Again, we'll take off the top 2 cards, put them to the side for later. Okay, 2 this time. Yeah, 2. Add up to 2 this time. 2 and 0 or 1, sorry, 1 and 1? Okay, 1 and 1. We'll do 1 here and 1 here. Okay. Take off our cards, put them on the side, and now just 1 this time. Do you want to switch the 1 on this pile or this one? This one. Okay. We'll do this one here. Okay. We'll switch those. Again, take off the top 2 cards. And now, even though my assistant has chosen all the numbers, if we've done this trick correctly, and if we trust math, then the 2 cards I'm left with in the middle, they should be a match. So 5 and 5. Here's where the trick gets really cool, is if we look at our other cards from before, our other piles, we have a match there, and there, and here, and here. Every single one of our piles is a match. Excellent. I hope you enjoyed that card trick. And sometimes people ask me, like, am I a real magician? And I will be completely honest with you, no. Every single card trick that I know how to do is all based on math. As long as you follow the rules, follow the pattern that I just did, it will work every time. But I'm going to leave it up to you to try the trick at home. See if you can follow the rules I did. If you need to watch it back later, that's okay. See if you can figure out, why does it work every time, no matter what numbers my assistant picks. I'm going to show you another trick. This one's not a card trick. This is a trick that has to do with numbers. Here's another trick. So get out my whiteboard again. Sometimes in life, we want to know if we can split things 3 ways. It's like if I order 6 donuts, here's my best drawing of donuts. 1, 2, 3, 4, 5, 6. If I order 6 donuts, I might want to know, can I split the donuts 3 ways equally? So like, can I split it between me and my brother and my mom? If you can split a number 3 ways, then we say it's divisible by 3. Here, with 6 donuts, you can see, yeah, we can split it into 3 equal groups of 2. So we would say that the number 6 is divisible by 3. But what if you have a really big number? Can you tell for a really big number if it's divisible by 3, if you can split it 3 ways? So here, let's choose a really big number. I'm going to choose a funny number I came up with just this morning. 111,111. 111,111. Okay, so it turns out there's actually a neat trick to figure out if a number can be divided by 3. All you have to do is you add up all the digits in the number. So I would do 1 plus 1 plus 1 plus 1 plus 1 plus 1. And you're following along at home. 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6 ones, so it's equal to 6. Now here's the trick, is that if the number you get by adding up the digits is divisible by 3, that means the original number was divisible by 3 as well. So as we saw before, 6 can be divided by 3. So that means that this original number, 111,111, is also divisible by 3. And we can try it with like any number. So let's just pick a random big number. Like I think before I did a number like 8173. Let's just see if this one is divisible by 3. Can you split this into 3 groups? So all we do again is we add up the individual digits. So 8 plus 1 is 9, plus 7 is 16, plus another 3 is 19. But is 19 divisible by 3? Well, luckily we have a trick. We can just add up the digits in 19. 1 plus 9 is 10. And now I know 10 can't be divided by 3. So this original number, 8173, you cannot split it 3 equal ways. So that's just a fun trick if you want to check quickly. If you have, for some reason, if you have 8,173 donuts and you have to split it between you and 2 other people, you can't do it perfectly. You're going to have to cut one of the donuts. Okay, let's see. I want to talk about some more. Those are just fun tricks you can try. I want to talk about some more real world applications of math. So at the Ontario Science Centre, our motto is ask, test, repeat. And I even have a t-shirt that says that, but what happened is I moved recently and I still have no idea where any of my things are. So I'm wearing one of my other math t-shirts instead, apple pie. If you tuned in, I did another stream a different day and I wore the same outfit. So don't judge me for that. I did wash it in between. But one question though I always get at the Science Center, particularly from dads who are trying to make like some sort of joke, is what are the winning lottery numbers? I know I don't condone gambling in any way, but there actually are ways you can use math to improve your lottery odds. So the lottery draw is completely random. So that just means there's no way to actually predict what numbers are going to win. But here's the thing, is if you do win and somebody else happened to pick exactly the same numbers as you did, then you might have to split your prize with them. So if you want to maximize your potential lottery winnings, the best thing you can do is to make sure you pick different numbers than everybody else. And now when people are picking their numbers, a lot of people will pick birthdays. So they could pick either their own birthday or maybe the birthday of someone they know. But the thing about birthdays is that they only go up to 31. Nobody's born on like January 40th, for example. So if you want to make sure you never match with people who are picking birthdays, you should always pick at least one number that's bigger than 31. Also, it might seem counterintuitive, but you should never, ever, ever play the lucky numbers that you see in something like a fortune cookie, because chances are somebody else got exactly the same numbers as you in their fortune cookie. There's actually a case back in 2005 where over 100 different people all won the same lottery. And it turns out that every single one of them got their numbers out of a fortune cookie. So they had to split the prize 100 ways. Now, the lottery is uses a lot of probability and statistics, so there's clearly a lot of math involved in the lottery, but it also uses a different kind of math called game theory. What game theory is it's a type of math that's all about trying to figure out the best strategy for playing games. So, in the example for the lottery, that means that you try to think about how everyone else is choosing their numbers. So, things like using birthdays or looking at fortune cookies. And then what you want to do is choose a different strategy. Lots of other games though, like fun ones you might play at your house, non-gambling related games, they actually use game theory too. And one of my favorites that I want to talk about today with you is rock, paper, scissors. So you might be familiar with the game rock, paper, scissors. In rock, paper, scissors, you have rock, which, here, I'll hold it up a little bit higher so you can see. Rock, which crushes scissors. Scissors cut paper, and paper covers rock, which for some reason defeats it. I don't really know. I don't get the logic to that. But anyway, at first glance, it seems like there's no strategy involved. That's just luck, who's going to win. But that's not exactly true. So here's one tip I have for you when we play rock, paper, scissors. When you play, normally you say rock, paper, scissors out loud. And because you say the word scissors last, it's stuck in your head. So a lot of people, more than a third of people, will start with scissors just because they just said the word scissors. So my advice to you is to start with rock because that's what beats scissors. But here's where the game theory really comes in and really gets interesting. So let's say you're playing against someone else who also watched this video. I just told both of you to start with rock. So what should you do? If you think your opponent is going to follow my advice and pick rock, then you should pick paper. But if you think that they're also thinking that way and that you're both going to pick paper, then shouldn't you pick scissors? Exactly. So one of the reasons rock, paper, scissors is so fun is because there's no perfect strategy to win the game. You can't win every time, no matter what you do. But I do have another tip to help you improve your chances if you're playing rock, paper, scissors. Some scientists and mathematicians did a study where they had hundreds of university students play rock, paper, scissors for hours. And university students will do pretty much anything you ask as long as you promise them free food. So I'm not really surprised that they agreed to do this. But what they did is they looked for patterns in how people play rock, paper, scissors. And it turns out that if someone wins a game, they're more likely to pick the exact same thing next time. It's like if you're playing against somebody and they won by playing rock, chances are they're going to think, oh yeah, rock is great, it just won, and they're going to play rock again a second time. On the other hand, what they found is that people are more likely to switch if they just lost. So if I pick scissors and I lost to your rock, I'm probably thinking, oh, scissors is so weak, I should try rock instead. Now, even with these strategies, you won't win every time. That's part of why the game's so fun, but they could improve your chances next time you're trying to settle a fight with a sibling. Like, if we don't have a number of donuts that can be split evenly, who gets the last one? Or better yet, you could try having a rock, paper, scissors tournament while you're at home. Put some of these strategies to the test. Now, I wanted to talk just a little bit more about a couple more things. I want to talk about my favorite application of math. I love sports, and it's coming up to the 1-year anniversary of the Toronto Raptors winning the NBA championship. Go Raptors. And when I found out that there's this whole area of math called sports analytics, which looks at how you can use math to get better at sports, that just became my new favorite topic in the whole world. So I just want to talk briefly. If you've been around me for any time, you'll know I talk about this all the time, but I just want to talk briefly about how math is used to play basketball. So I'm just going to draw my little basketball court for you here in green. You've got this key in the middle, got the basket down here, and then you have a 3-point line around the outside. Okay. And when you're doing math to assess a game like basketball, what we're actually trying to figure out is where's the best spot on the court to shoot from? What earns us the most points on average? And what the biggest finding was of the last 10 years is people started to realize that even though it's harder to hit 3-pointers from out here, because they're worth that extra point, it's actually a more valuable shot than anything inside here. And actually, the best 3-pointer to shoot is this one in the corner. Because the 3-point line bends a little bit, and it's actually a little bit closer in the corner. So when you hear people talk about basketball and they talk about shooting 3-pointers, what they're really talking about is how they figured out using math that you can play basketball more efficiently. It turns out, though, that actually the best thing in the whole game that you can do is shoot free throws. Because free throws go in 80% of the time. People in the NBA are really good at shooting them. And if you get fouled while you're trying to shoot a 3-pointer, you get to shoot 3 free throws, which actually turns out is the best possible situation in the game, even better than a dunk. So if you're worried that, oh, I'm too short, I can't make the NBA because I can't dunk, well, don't worry. There's something even better than dunking. Even better than dunking is to get fouled while you're trying to shoot a 3-pointer. That's the best play in all of basketball. Okay. I just wanted to be able to talk briefly about how the Raptors won the championship. It's been a year, but I'm still riding that bit of that high. I don't want to keep you here forever, so I do want to wrap up soon. And first of all, before I do my final demonstration for you, I just want to thank you so much for tuning in, because I know it takes a certain kind of person to see an advertisement that's like, hey, come do math for fun at 1 p.m. on a Monday and be like, yeah, that's for me. So I want to thank you so much for being open-minded, for having this enthusiasm for math, and for giving it a try. As we say at the Science Center, ask, test, repeat. And we really mean that we want you to ask questions, be curious about what's going on around you, but then actually try things out for yourself. So if you didn't get a chance to try any of these experiments for yourself, my advice to you is watch it back after and see if you can replicate any of the calculator tricks or card tricks or just my rock, paper, scissors strategy at home. I might not be able to see or hear you right now, but I just want to thank you for being out there. My mom even said she was going to watch. So Mom, if you're watching, thanks, Mom. I want to leave you with my most popular math trick. And I mean popular within the sense of okay, it's still math, but it's popular within the math sense, is because whenever I do this trick, people seem to like it at the Ontario Science Center. So what it is I've taught myself a way that I can use math to figure out what day of the week somebody was born. So how it works is if somebody gives me their birthday, I can do a short calculation and tell them if it was a Monday, a Tuesday, a Wednesday, something like that. So I'm going to get my my off-screen colleague to feed me a birthday. Okay, May 12th. Oh, that was just recently, May 12th, 1964. 1964. So maybe someone of the vintage they might have seen Good Will Hunting. Okay, excellent. May 12th, 1964. So don't worry if it doesn't make sense right now where I'm getting these numbers from, but I am going to do a little bit of a calculation. There's a lot of different ways to do this because the calendar is very predictable. It repeats in a very predictable way. Like if my birthday was on a Tuesday this year, it's going to be on a Wednesday next year, and then a Thursday the year after that. So we can use this idea that the calculator repeats in predictable ways to figure out the day of the week. The way that I do it, though, is I try to figure out one special day for every month. So I have one special day memorized for every month. My special day I have memorized for May is May the 9th. And what I'm going to try and do is use some math to figure out what day of the week was May 9th in the year 1964. And then from there, I can figure out what day May 12th was. So here's the math I'm going to do. 1964, that was in the 1900s. My code for the 1900s is the number 3. I'll just draw it a bit bigger here. Number 3. Excellent. And now I am going to, because it's 1964, I'm going to count how many times 12 goes into 64. It actually turns out that 12 goes into 64 5 times, and there's 4 left over. The last thing I have to do is, in certain years, called leap years, the calendar advances an extra day. So I just have to figure out how many leap years would go into 4 years. Well, leap year is every 4 years, so there's going to be one leap year, one extra day I'm going to add into this. And then I'm just going to add up these numbers. So 3 plus 5 plus 4 plus 1. I'll let you follow along at home. I get, what is that? 13 when I do that. Now, there's not 13 days in a week. So I'm going to take away a whole week worth of days. I'm going to take away 7 whole days. And that's going to leave me with, here, I'll write it over here, 6. Okay. Now, in my code, Saturday is the 6th day of the week. So what I've just calculated is that in the year 1964, May 9th was on a Saturday. May 12th was 3 days after that. So what's 3 days after Saturday? Well, that would be Tuesday. So if we've done our math correctly, our volunteer was born on a Tuesday. Okay, and he's giving me the confirmation that that is in fact correct. When I do this at the Science Center, I find that oftentimes like parents don't remember the day of the week that their own child was born, which makes sense because you're probably like kind of busy. You had other things going on at that time. And kids often don't remember what day of the week they were born either. Probably because they don't have a lot of memories from that. I want to leave you with that trick today. If you ever see me at the Science Center, or if you find me online through the Ontario Science Center social media, you can feel free to give me your own birthday. I can try and figure out what day of the week it was, or answer any of your questions about math. I want to, on behalf of me and the Toronto Star and the Ontario Science Center, say a big thank you to all of you for coming out and joining me. I know it was a quick half hour. I hope that the time flew by for you as fast as it flew by for me. And the thing is, we only know how much time has elapsed because we invented numbers and we use those on our clocks. I hope that as you go through your life, you start to notice where math pops up more and more in the world around you. And I want to thank you so much for your enthusiasm. All right, have a great rest of your Monday and have a great week, everyone.